Hey, hello, we are Team AJ. These are our team members. A CPU scheduler is a process which selects processes in the ready queue to allocate to the CPU and allow the process to execute. Then decides how when to deallocate that process depending on the design of the scheduler or based on interrupts. The CPU scheduler aims to optimize CPU utilization, increase throughput, decrease turnaround time, decrease waiting time, and decrease response time. There are many different CPU scheduling algorithms, with the most common ones being first come, first serve, shortest job first, priority scheduling, round robin, multi-level queue scheduling, and multi-level feedback queue scheduling. These algorithms may be categorized into preemptive or non-preemptive algorithms, with preemptive meaning that the scheduler may stop a currently executing process anytime to schedule another process. And conversely, non-preemptive being that once a process is executing, it may not be preempted until it completes its designated time.
For this presentation, we will be discussing about the baseline CPU scheduler, specifically about the design choices, features, and the algorithm it utilized to schedule processes. It is clear from the code that the baseline CPU scheduler is comprised of a combination of two different scheduling algorithms, first come, first serve, and round robin with time quantum of 8. First come, first serve is an algorithm that allocates processes to the CPU in the same order that they arrive at the ready queue. This algorithm is very easy to understand and implement, but often has longer average waiting time, which result in lower CPU utilization. This algorithm is also associated with an effect called conveyor effect, where the short job arrive after a long job, causing the short job to have unnecessarily long waiting time. The design choice of the baseline scheduler to use a queue data structure was due its first in, first out property, which complement with their first come, first serve algorithm. When a process arrives, we can use the predefined pushback function to add the process to the end of the ready queue. While if the process has finished executing, we can use the predefined popback function to remove the front process of the queue. Round robin is an algorithm where each process is in the ready queue takes turn after one another, executing with an equal allotted amount of time. This allows all processes to get a fair allocation of the CPU, resulting in no starvation or conveyor effect. Some disadvantages of this algorithm are that it increases the amount of context switches, which is an overhead for the system and usually has longer average waiting time and response time depending on the time quantum. The design choices made to get the effect of round robin was to have a variable with fixed value to hold the time quantum, which was used to calculate the time when 2 p.m. the current process and schedule the next process in the queue. The round robin algorithm has the first in, first out property, so the use of a queue data structure was the best choice.
In conclusion, the algorithms used for implementation of the baseline scheduler made it easy to understand and implement, and reduce conveyor effects and starvation, but does not account for the priority of processes like some of the other common CPU scheduling methodologies. Each scheduling algorithm has their pros and cons, so it's up to the system developer to decide how they implement their CPU scheduler depending on their system requirements or preferences. Thank you for your listening.